Hi, Mr. Pierce here again. We're going to investigate transformations of curves, and this time we're going to take the curve f of x equals x squared, and we're going to multiply inside the brackets now. So we're going to multiply x by 2, thereby changing the input number. So by doing that, we actually have 2x all squared, which means that we have on the right hand side, we actually have the curve 4x squared, because 2 squared is 4. So we're going to multiply inside the brackets now and see what happens graphically when we do that. So let's get on GeoGebra. And as you can see here, I've got f of 1x is 1x squared, the curve here. So if I transform that to f of 2x, multiply inside the brackets, I get 2x all squared. So this curve here is actually 4x squared. So let's analyze what's happening to each one of these points as we transform this curve. As you can see, the x part of the coordinate here is 1. And what's happened here is that's been divided by 2. 1 divided by 2 is a half. So the x coordinate has divided by 2, but the y coordinate appears to be remained unchanged, so 1 has gone to 1. Let's look at this coordinate. Again, the x part of the coordinate, 2 to 1, that's been divided by 2 as well, but the y coordinate has remained unchanged, it's still 4. And with the last point here, 3 has been divided by 2 to get 1.5, and 9 is still 9, so that's remained unchanged. So what appears to be happening is the x-coordinate has been divided by 2, and the y-coordinate has remained unchanged. Now let's see what happens if I change k. Let's say if I change it to 4. So if I multiply inside the brackets by 4. And what that will give me is that will give me 4x all squared, which is actually 16x squared, this curve here. So let's just analyze the points again and see what's happened as that's transformed. So 1 has gone to 0.25, so it looks like it's been divided by 4 here. So the x part of the coordinate is divided by 4, and the y part of the coordinate has remained unchanged. Here 2 has gone to a half, so it's been divided by 4, and y is unchanged. And 3 has gone to 0.75, been divided by 4 again, and 9 is unchanged. So it looks as though the x part of the coordinate is changing and not the y part of the coordinate. And as you can see, if I just change this, you can see this is not a translation. Again, this is a stretch in the coordinate grid. It looks like squashing towards the y-axis as the input is getting bigger. If we multiply by a larger number, it looks like it's squashing towards the y-axis. And the correct mathematical term for that is a stretch. So this is a stretch, not a translation. So let's go back onto here, and let's try and explain mathematically exactly what's going on. So again, this is a stretch, so we'll write that down. To go from here to here, what actually happened? Well, the x part of the coordinate was divided by 2. But if you know anything about maths, you'll know that that's actually the same as multiplying by a half. And when we saw dividing by 4, that's in fact the same as multiplying by a quarter. So when we describe this transformation, we say it's a stretch, and we say it's a scale factor a half. But if you remember, that was only in the x direction. So I'm just going to say in the x direction. Just get rid of this stuff. There we go. And if I just do the other example, so if I transform from f of x equals x squared to f of 4x, which is 4x all squared, which is actually 16x squared, then again that's a stretch of scale factor 1/4, and again in the x direction. So if we talk about what's going on in general, if I have, say, f of kx, if I multiply inside the brackets by k, then I get kx all squared. And to describe that, that's a stretch of scale factor 1/k in the x direction. So when we multiply inside the brackets by a number, what's actually happening is we're stretching scale factor 1 over that number in the x direction. Hope that helps. See you soon. Bye.